Today we're working on 2.5, which is properties of number. Today's lesson is going to be a little different than typical. We're definitely a lot of content heavy at the beginning with just a very few examples at the end. So let's get right to it. On your sheet you can see that I've listed all the properties. I have chunked these out to hopefully help make a little more sense. First one is commutative property of addition and of multiplication. The whole concept behind commutative is that you move the order that these are in. Okay, so you can notice here a plus b is the same as b plus a. So all it was done is that these were flipped around. 3 plus 7 or 7 plus 3. This is going to get you 10. And this is still going to get you 10. So therefore they're equal. Multiplication, a times b equals b times a. Once again, these two are flipped around. So you can intertwine the order, and it does not affect addition and multiplication. Your other operations it would, but addition and multiplication it does not. One way I use to remember this is that O and M, the double M, is kind of how I try to keep that straight. And my concept for here is your order can move. Okay, so you're gonna have to find ways and tricks to help you remember which rule is happening for which, like what that means. I truly believe that with all these concepts today that you can understand what they're saying. However, remembering which is probably the toughest part. Associative property of addition and multiplication is saying pretty much is very similar. What this is saying is that you can move your parentheses. So in here parentheses was a and b, where on this side the equal sign it's b and c. It's still going to give you the same thing. So 6 plus 4 is 10. 10 plus 5 is 15. Where this is 4 plus 5 is 9. 9 plus 6 is still going to give you that 15. So 15 equals 15. That works. Same concept with C. I try to do this one with arrange your parentheses. How do I remember the parentheses piece? I just try to stick with, okay, it's my arrange my parentheses, and that these two words have to go together. Where going back, I put the double M move, so you can, the order can move, and went that way. So double M was for move, or here. You can arrange your parentheses with that way. There's two S's, so two parentheses, you just got to be careful. There's two M's here, but M is going with move, so hopefully just two different, a way I use to kind of keep things straight. The next property is identity. Identity is very similar to the one following, which I can flip to, is inverse. So trying to keep these two straight is important. Identity, what I have remembered is put the ID. Okay, your ID identifies you, and it's always going to give you like you. So a plus 0 is a times 1 is still a. So you're always going to get you, or whatever you started with, type of a concept. So once again, identity, here's an example, 9 plus 0, still going to give you 9. Anything you add 0 to, you're going to get itself. Anything you times by 1, you're going to get itself, which is why I'm trying to help you with the concept of like an ID, identity. You're going to get what you started with. You're going to get yourself with your ID. Now, inverse, how is that different? Your inverse here, I would just try to somehow remember opposite, somewhere along the lines of opposite. Positive a, so the opposite, you're going to add the opposite, which is a negative a, you're going to always get 0. You're going to always get 0 for the inverse property of addition, and for multiplication you will always get 1. So what's the opposite? Well, a, you do the reciprocal, and it's 1 over a, so you multiply these together, you get 1. So inverse is opposite. Addition, you always get 0. Multiplication, you'll get 1. The last one out of that box is the symmetric property. What this is saying is that you can intertwine them because they would work. So here, if A equals B, then B equals A. So if I said 2 times 3 equals 6, so then 6 has got to equal 2 times 3. What they're doing is that they're moving what's on which side of the equal sign. So think symmetric. Concept is symmetrical, so draw a line in between it, and that they would flip together and be the same. Our next box that we have is properties of real numbers. The distributive property is just stating little rainbow, big rainbow. So we have A times B plus A times C. And then the same thing holds true when it's subtraction versus addition. So little rainbow, big rainbow, AB minus AC. And you can pause the video, take a look at these examples if you still have questions. The last ones we have is the multiplication property of 0 and multiplication property of -1. So anytime that you're multiplying something by 0 and you get 0, you can state that this rule is the reason why that works. And same with multiplication property. When you times anything by a -1, you're going to get a negative n. So if this would show up when you're trying to use your deductive reasoning to state things out, these are 2 other additional rules that you can use. So that is all of our content for today. But now let's take a look at a few examples here yet. Okay, so asked to name the property that is illustrated. So here we have 3 times A equals A times 3. Okay, what I see here is the order or the movement of your 3 and A has been moved. So if you go back to your notes, which one did we talk about? The order and movement had been commutative. So the double M, the movement, you can flip these around, does not have any parentheses. So that's how I knew associative was not a part of this. So then it had to be commutative. P times 0 equals 0. Okay, we're multiplying something by 0 and we get 0. So what property is that? It is the property of 0. Multiplication property of 0, I should say. 6, you have 6 plus a -6. So I see opposites here, and that was supposed to be opposite with inverse. So the inverse property, and they are adding, so it's the inverse property of addition. The other one was the inverse property of multiplication. Obviously they're adding, so it's inverse property of addition. Your assignment tonight is going to be full of justify and use like deductive reasoning for what's actually happening to be able to identify that. And I just want you to know that deductive reasoning is just you're explaining like logical steps that are happening using these properties or rules. So let's take a look at the next example. It says buy a shirt for $14.85, pair of pants for $21.95, pair of shoes for $25.15. How much total did you spend? So we got to add them all up, but there's no specific order. On this side of my equal sign, they went straight in order of what was listed. Here they intertwined your 25 and 21. So this would be, you moved the order. So what is that showing? Well, movement, the order moved would be your commutative property. Here I put in parentheses and did these 2 first. So as soon as you put in parentheses, your arrangement, your A arrangement of parentheses should have kind of ringed the bell, and you knew that would have been the associative property of addition. It would be your next, what happened. See here in green, you're going to get 40 plus 21.95. It's a simplifying step. And once again, simplify to get 61.95 is what the total amount you spent. Last example says simplify and justify each step. So what's going to happen first? First thing I see is little rainbow, big rainbow. So taking a look, you can see here in red, little rainbow, big rainbow, which is considered the distributive property. So that simplifying piece is the important piece today. Now, I've seen two x's, so what are you going to do? Well, I can pull out an x, which would be the distributive property again. Simplify or subtract what's on the inside, you get a negative 1x plus 32. So, identity property, anything you times by negative 1, you're going to get itself, so that's that identity piece, so you just get negative x plus 32. Like I said before, you can tell that it's definitely maybe not so much more on the math side, but simplifying. It's just being able to justify an answer and state what's happening based on the different properties and rules we have in math, which is why that front page of your notes is so important for today. And that is all.